Hey there, we're just going to get started on this first module. It's called the case for Hadoop. And what we're really going to focus on here is just basic objectives to understanding what has driven Hadoop to be so excited, for folks to be so excited about Hadoop, what has happened in data that has driven this heavy adoption. Definitely we'll talk about what the current data architectures out there, how they are falling short adapting these drivers that are surfacing Hadoop. Run through some pretty well accepted use cases that seem to have a very horizontal slice across almost all verticals. Most everyone can use these technologies. We're not limited to those, but definitely want to share those with you. And then want to run through the importance of and kind of the definition of open enterprise Hadoop and how the Hortonworks data platform HDP fits that well. And lastly, we'll make sure we really firm that statement up that, the modern data architecture as we go into the future is definitely powered by Hadoop. So what got us here? No good Hadoop conversation can happen without talking about the old 3 V's. It's volume, variety, and velocity for sure. How fast that data is coming at you. It's one thing to have a large amount of data, but to have a large amount continuously coming at you from a variety of sources, that is the real kind of driver that's got Hadoop off and running and rolling. And this graphic is going to show you a good spread and things that make a little bit of sense from most of us from running maybe an IT organization. Definitely our core systems that we run our business on, our ERPs, and then as we expand out, and those are, we have a certain number of products, we have a certain number of orders, and those type things, certain number of partners, those things, supply chains, etc. But as we start getting out into the customer relationship management software, we have a lot more data because we're chasing down possibilities and trying to drum up business that drives into our ERP systems themselves. And that can get much more sophisticated. The CRM space has definitely grown up a lot in the last 10 years. And as you keep scaling out, and you look at the greater web, a variety of information starts coming to bear, and not just things that actually occurred, but things that might have occurred and reasons why, those kinds of things. So lots of good cookie crumbs there. Obviously, it's kind of a driver of one of the early Hadoop use cases around weblog analysis. And then we really start getting into that richer big data space that definitely comes out of humans driving content, driving opinions, driving behaviors. But just as much, it's about technology, sensors, devices. So there are human aspects, and devices can be human-oriented, watches, phones, those type things for sure. And then there's kind of somewhere in the middle, those, your car, what is it doing every second? How is it interacting? And then definitely further downstream, what is a jet engine doing across a transatlantic flight? What's a wellhead doing at any given point in time? So that kind of data, you're out there now. You're scanning past the petabytes. You're out there and the exabytes, and you're looking at data beyond that, beyond exabytes, ultimately out to zettabytes as well. Just some more definitions of those 3 V's, the volume, velocity, and variety. And I think the color coding or the size of the font and etc. is kind of helping you express that. I think we get it. Volume is just an enormous amount of information. But you couple volume with velocity, where we continuously are getting. It's one thing to say I've got 20 years of data, and that's a lot. But if I'm getting that kind of historical footprint of data every day or every week or even every hour, whatever's appropriate for your environment, that's a big difference. That changes a lot from how we attack and we resolve information. And then variety. We're getting information, as you saw in that previous slide, as we scale out past the classic systems that we drive our businesses on and drive our enterprises, and looking out to the futuristic collection of information, data that's out there, systems are happening, but now we're actually being able to collect that and drop it. That does often, almost always, bring data back in a variety of technological sources for sure, JSON, XML, lots of other things. but a variety of, maybe the data itself isn't very, quote unquote structured. It could be just, the classic there obviously is tweets and micro blogs and those kinds of things that we have to kind of take that information, try to decipher that and try to understand it. So just a couple quick slides on each one of those, the V's like we talked about there. And I think I skipped from petabytes straight to zettabytes. So petabytes, exabytes, zettabytes. And I think we've talked through some of these in the last moment about, obviously transactional systems got us there. But as we talk about people and machines, people using machines, people doing lots of things with machines, or machines running on their own, we're really talking about that massive amount of data. Work with the customer who's in the aircraft business and thinking of all those sensors. And we're talking about small aircrafts could even have several hundreds of sensors that can report sub-second. And what do you do with that kind of information? How much data is that? And, what kind of insights can you glean from that? And the problems, as you see there, where it was hard to collect that information for sure, but it was definitely hard to hang on to it. Maybe we had an opportunity to glean it and look at it, but we quickly had to throw it away because we just couldn't lay that kind of information down. So we want to do both. We want to grab the insight as the data is coming in, but we want to also continually to push that into the back-end system so we can analyze that and then further influence that real-time stream of information on the front end. And again, we're talking through these velocity. We just talked about that. How much data you have per what? Second, minute, hour, day. And it really is going to depend company to company, marketplace to marketplace, vertical to vertical, etc. And, it is not just that the velocity is so intense. Velocities are going to actually have peaks, just like anything else in life. You're going to see things that actually might be 10, 100, or more X amount of volume in a short period of time, or even a elongated period of time. And this is really, one of the definite cornerstones. And then we talked about variety, definitely technological variety, of file formats, etc. But just the kind of data, as you see there, yes, emails, we just talked about that stock ticker, maybe tweets, but it could be audio and video information. Large rail customer has cameras looking out how their train cars are going down the tracks, and by the fact that train cars may or may not sway a certain amount or too much, or how much of frequency may drive that rail system to decide maybe there's a potential problem in the track that we need to go back and invest some time and effort to investigate and potentially service. So we're looking for insights that help drive your business, whatever your business really may be. So this is a quick some output of a study from EMC. Obviously, the data studies work. By the time they get it out, it's a little bit later. But EMC was suggesting that in 2013, the entire digital universe, all over the place across this great world of ours, was in the neighborhood of 4 zettabytes. But now that we really are turning up, definitely we talked about this, human content, humans using devices, and then the Internet of Things is the phrase we'll throw out there. Meter heads, sensors, all kinds of things that are massively throwing data at us. That same study has projected that the size of data is going to be easily an order of magnitude bigger. They project 44 zettabytes by 2020. It's 2016. These days are coming. We can go back and really evaluate and make sure this really makes sense. But this is the real driver for this notion called big data, and definitely the driver for the adoption of technologies such as Hadoop. So why not, why not just keep doing what we're already doing? Well, end of the day, the technologies that we have in place, they simply either cannot solve the problems we're talking about, or they can't solve them in an affordable enough manner for you to really take advantage of them. Something reminds me of that Einstein quote about the intellect that got you here to this problem is not the intellect that's going to get you past it. So we've got to get past it. We've got to look to Hadoop, and Hadoop has become that de facto foundation for the entire big data industry. Definitely there are other technologies at play, and definitely Hadoop and Hortonworks believe in this notion of a +1 architecture that's there's many other elements wrapped around it, but But I think it's fair to say, and I think most everyone would agree, that Hadoop is that foundational technology that's going to drive us. So what is Hadoop? This is just some bullets right off the Hadoop project site itself. And all good open source projects are going to describe themselves well. And I think it says it best. A couple key points in there. It's a software framework. It's not it's not a hardware solution. And the intention is that software framework could run on many machines, what we call a cluster. Exposing simple programming models. We'll talk through many of those today. And scale from a single machine, sure, or a few machines, or 10 machines, or 20 machines, to thousands of machines, and ultimately pushing this notion of computation and storage at every element of the cluster. You'll see later why having compute next to, or co-located, or data local to the data itself is again kind of an architectural tenet of the Hadoop solution. And just, anytime we have lots of hardware, we got to expect failures, and Hadoop is built with failures in mind. The whole system is constantly on the lookout for problems, and is focused on recovering and moving on and going past that. And we'll definitely explore some of those things. So, if that's Hadoop, then there's this phrase that we like to call open enterprise Hadoop. So it's not just Hadoop, it's Hadoop for that runs anywhere, collects anything, has any kind of workload engine that sits on top of that. So if you just kind of walk that chart from the bottom up, we're saying in the cloud, on-prem, Linux, Windows, or some hybrid of all the above, okay, let's do it. The kind of data we're talking about, that's what we just talked about, from definitely from variety of data, and definitely the volume and the velocity, but the variety of data we're talking about. Ingest information from anywhere, bring it to Hadoop, and bring it early. Bring it as a schema on write concept. Do a extract load and transform it later. Shift that burden to transform that data, make some decisions about it, because when we really start applying structure or cooking data, we actually make a perspective, add a perspective to data, and then it's hard to look at that data differently. So we definitely believe in bringing data in the raw, as raw as possible that you can, and then potentially produce many other visions and understandings and perceptions and of that data as we go along. So that data sits out there in this big, large grid, and then at the central core of all this is a concept called Yarn. We'll definitely talk about the operating system of Hadoop. And Yarn is a compute foundational element for many workloads. It's a phrase we like to say, workloads, and we think of things like batch and real-time search, NoSQL, machine learning. So you see some of those possibilities and descriptions across the top. So Hortonworks brings you all of these things. And in fact, we try to bring that word enterprise to bear, which means we bring these things with maturity, with administrative tools, with security, governance, all those tools that really matter to large enterprises. So where do we see once, so that's what's driving us. That's Hadoop's the answer, but okay, what is it? What can we do with it? And like anything that we talk about technology, we do two things, a combination of two things fundamentally. We either find something new that we could do to help our business, so a business outcome, a new feature, etc., or we save money. So if we think about the first one, what are some of the the three large kind of families that we see things that fall under, as you see across the top? Single view, pulling together the fact that maybe I've got 5 or 6 ERP systems, if I can pull them together and get a consistent view of my customers, of my partners, etc. Many other things. It can not just be those; it could be potential customers too. Data discovery, I can learn more about information by having the information, by having my entire breadth of my cell phone data, where customers are, what they're surfing, what kind of uses. I get a lot more understanding of my customers, and that's very valuable. And what do we do with all this? Or really, the sacred cow, the golden goose we're going after is this notion of predictive analytics. We want to find out what's going to go wrong, or what we have to do to do something to go right, to save money or make money. We talked about the trains. We talked about, alluded to the fact that aircraft manufacturers, why do they want that information? They want to find out if they need they want to spend money at the right time to overhaul an engine, to fix, repair, to consult a pilot about their behaviors, etc. So it's all about finding out what we believe will happen next. So a wellhead out in an unmanned oil rig. Let's don't send someone out unless we have to, but let's don't wait too long. Let's find the right answer. So let's find new things we can do, or let's just save some money. Easy ones here, very classic. So I'll give you data enrichment because it kind of fits in what we just talked about there. If you can bring more data sources to bear, or even mudge the existing data sources together, you can enrich the data. But the two real classic cost savings ones are just maintaining data for long periods of time with richness and robustness of not losing that information. We call it an active archive. Is dramatically cheaper than most other long-term data storage mechanisms, or definitely the online elements. So even we believe Hadoop is cheaper overall than even your tape solutions. And by bringing them and storing them in HDFS, the file system of Hadoop that we'll talk about, we actually have that information available for any of these use cases as well. It's not just that we're maintaining it's in cold storage, it takes a day, a week, an hour to find. We have it available for us right now. And then right down the middle, we know this notion of ETL offload. We spend a lot of money in most organizations running through that enrichment, cleansing, etc. of information, and we pay a lot of money for those tools, and they run on specialized clusters. So a good percentage of those jobs that we do day in and day out, we could very easily convert them to run in a Hadoop grid, a Hadoop cluster, and save lots of money. So again, let's find new things to do, or let's save some money. And what's the right formula for this? How fast you should go down this? What should you do first? In this, set of families, well, that's going to be dramatically different from customer to customer. It's going to depend on what's your drivers. It's going to depend on your risk register, how comfortable you are to do something new and bet the farm and those type of things. But some combination of exploring, optimizing, and transformation is going to be in transforming your business is right for you. And the best thing I would say is get started. And I would say for most organizations, it's try things that are very well understood. They have a pretty immediate return on investment. Well, and there's a rich history of others doing that, so you have that confidence and belief, and definitely can look your boss in the eye and say you made a good choice. But sometimes businesses really have a problem they need to solve, and this may be the technology and the solution. In fact, that's what I did at a prior financial institution before I came to Hortonworks, and that we did something there at that organization that we just couldn't do. We've been trying for about 2 years, and we did in about 6 weeks, thanks to the power of Hadoop. So if you take all those kind of use cases and look past the families, and then try to take those and apply them to verticals, this is all this slide is trying to show you what are some of the common, fine-grained use cases that might make sense via your vertical. So I'll pause and just kind of let you take a look at that, especially if you align with one of these vertical segments. And then I will spend a few minutes and run through that phrase I said, open enterprise Hadoop. That is itself, these kind of foundational things, open, central, interoperable, and ready, and we'll discuss those in each one of those spaces. Open is about, as you can imagine, everything's in the clear. When Hortonworks, in particular, believes strongly and 100% open source. And we don't just mean, Lester opened up a GitHub project and said, please come contribute. We mean the Apache Software Foundation managing that project, giving some guidance, controls, not controls, I guess you can say, ways to run a software project so that they encourage collaboration and community. So we believe strongly in that. And definitely, we also believe, if for no other reason, the old many eyes against a problem, we're going to ultimately and surely have a better solution. So we're going to have much more innovation in that space where we're not limited to a certain engineering team in a closed solution environment. So everything we do, we believe strongly. In fact, we've acquired companies that we've turned around and turned that software back into open source just because that's just what we do, and we 100% think that's the right answer. And this deck here, this slide here will be something we'll definitely cover as we get into the larger Hadoop stack and the various components and the categorizations you see across the bottom. But where I really wanted to point out was that, you know, Hadoop, a modern Hadoop distribution, is a culmination of a bunch of projects. In our case, you know, Hortonworks' case, it's a bunch of Apache Software Foundation projects, and you know, just to reaffirm our commitment to 100% open source solution. So again, we'll run through those technologies as we get a little deeper. Open Enterprise Hadoop is definitely, you know, centralized. So I guess the phrase to say is at its foundational element, Yarn is the data operating system we talked about a moment ago. That is the cornerstone, the central element, controller, multi-tenancy engine that everything's going to run within. And it allows for, as we said, a variety of workloads or a diverse application of diverse workloads. And you see there maximize data ingest, shared big data assets. It's all about multi-tenancy with sharing, you know, finding that right mix of letting your business units share that information where it's appropriate, and definitely let them shield and protect where it isn't. And just some basics, you know, under this kind of on the left side here, efficiencies and how easy to expand, why this is really much more appropriate than. And when we say proprietary Hadoop, obviously we're talking about solutions that may be either 100% proprietary or some combination, but just as much historical Hadoop would fit in this as well. So ease of expansion is a great one to imagine, and it kind of comes from resource efficiency. We used to build these purpose-built clusters to solve specific needs, and every time we have a new use case, a new application, a new set of data, or customer, etc., we might in fact spin up another cluster. So we're definitely focused on this Yarn-based, multi-tenant, lots of controls around sharing and enforcing folks and teams and organizations' data can coexist together. And interoperability, I said it, you know, we're a +1 architecture. I wish I could tell you Hadoop would turn everything else off. That's not the case. Hadoop will turn things off for sure, but Hadoop is another technology that you're bringing into your data center. And why bring it in? Because it solves this problem we mentioned earlier that just can't happen with the technologies you have today. So bringing Hadoop into the space, into your data center, will let you further expand to and incorporate and ingest even more and data sources, you know, as it says, any kind of data, and then ultimately run any kind of application with that data. And as we said it best, anywhere, whatever that combination of OSs or on-prem, off-prem, those type of things. We can do all those things. Flexibility is critically important to us. And in fact, part of that is a concept called Open Data Platform that Hortonworks, Pivotal, IBM, and others created. I think that was last year. And to build hey, what is that foundation so that people can then further stack upon that and feel confident. So it's definitely an important part of that interoperable piece. But all those things don't really matter if we're not ready to go. So Yarn's there, Hadoop's there, HDP, Hortonworks Data Platform is there. And again, what are we looking here? Yarn driving all this, but we definitely want to see, as you see, kind of operations, governance, and security. You know, we want to be able to, in an enterprise manner, install, configure, start, stop, monitor, you know, provision your system, your Hadoop environment in a centralized way with a single pane of glass, and then integrate in other places where it makes sense that you see that's the case. Governance is a huge piece. We're talking about data. We're talking about the metadata of data. We're talking about the lineage, the pipeline, where did it come from, who's seen it, etc. So that's, you know, cornerstones and definitely elements that we're attacking in the, you know, open enterprise Hadoop space. And what would be, how could we not talk about security when we're talking about data? So, you know, that's part of that whole enterprise word that we've been growing up, and we'll definitely spend some time today talking about security and the history of how we got here today. But it's the A's and beyond: the authentication, authorization, audit, data at rest, data at motion, encryption, auditing, all those things, and administration to pull it all together. Very, very critical. So we're ready with all these technologies. And while I was talking about it in generic terms, I definitely want to call out a couple technologies here. I want to talk about we're ready with Spark. We're the first. Hortonworks with version 2.4 that just recently GA'd is the first product that supports Spark 1.6, which is incredible. There's a much excitement, focus, innovation, activity in the Spark space, and we're on board. We're committing. We believe in. And we're enthusiastic as well about Spark. So we'll definitely talk about Spark. But, I also want to say that while there is significant interest, again, in Spark, significant growth, adoption, etc., today at least, that the diehard workhorse that we see in Hadoop for almost everyone, 9 out of 10 Hadoop cluster environments have a heavy utilization on Apache Hive. And there's been a lot of significant innovation around the Stinger initiative, the Stinger.next initiative, to really make sure that Apache Hive solves massive amounts of analytics, interactive queries, etc. So we definitely want to make sure everyone understands we're ready with Hive as well. So why Hortonworks? You're going to use Hadoop. We got it. You're here. You want to talk about Hadoop? We advocate Hortonworks, of course. For those reasons we said earlier, runs anywhere, anytime, anywhere, any kind of data we bring it in from any kind of source, ingest it. We can run any kind of workload against that data, all within an enterprise, secure, auditable, governed manner. And just to kind of wrap up this section, while we're going to focus on Hadoop and again more about Hadoop than about Hortonworks Data Platform, but of course HTTP. It's part of a bigger picture around big data management as a whole. So we have a set of products that we lump together, just like we call our Hadoop products. We have a thing called Hortonworks Dataflow. One of the foundational elements is Apache NiFi. And again, that's about that as the data is coming in. How do we do something major and dramatic with that information and use it in such a way that's extremely powerful? How do we take those perishable insights and consume them immediately? But simultaneously, dropping that information. For those that are familiar with the Lambda architecture, this probably makes a little bit of sense. So we glean that information. We definitely store it. Why do we store it? Because we're continuously running and revising our analytics and ultimately sharing that information back out, as you see on the right there, in rich context, so that those perishable insights can continually reap the benefits of the output of doing those analysis on deeper and richer and wider historical information. So kind of reached the end of this intro section. I'll just run through a couple questions, make sure folks were staying awake and listening. I guess first one is listen. Give us what are the 3 V's, and I think I mentioned them earlier: volume, variety, etc. Volume, variety, and velocity. Thank you. And I think we talked about those. What's after a petabyte? Exabytes and zettabytes, I believe. Exabytes and zettabytes. And what organization? Well, it's not Hortonworks, even though some might think that's the case. We definitely are a major contributor, a major player in the space, but it's the Apache Software Foundation itself that I would say manages Hadoop. And again, it's a framework around how software products can be managed. We ran through the 6 common use cases where the most sought after one of that, ETL offload, data archive, data enrichment, those type things. The biggest one that we really focused on, single view. The biggest one we were thinking about is predictive analytics. That's the space that we're all really, most everyone is really sinking after. And as a quick summary, this just kind of recaps what we just talked about there in the question and answer, etc. So that takes us to the end of the first module, and we'll pick it up in just a moment with the second.